The first 6 problems are literally just what quadrants are you going to be able to use. And I didn't line them up across from each other. I mixed them all up so you'd have to actually think about it. The odd ones are in 1 or 4. Which ones up here are odd? Could you give me one that's odd? All right, sine is odd, so that would be 1 or 4. What else is an odd one? Tangent? And then the reciprocal ones go together. So what's your reciprocal of sine? Cosecant. And then your reciprocal for tangent is cotangent. So those are all the odd ones. The even ones, which are the other 2, what quadrants are those ones in? 1 and 2. So if it's positive, it's in quadrant 1. If it's negative, it's in whatever the other option is. Okay? Off we go. Number 7. It is negative. So what quadrant is that going to be in? 4. Draw a triangle in quadrant 4. -1/2 is the y value because sine gives you your y value. What is the angle across from the 1/2? Or well, this side will be square root of 3/2. But what's the angle that goes across from this? It's pi/6. Good. Your answer is not pi/6 though. It's how much you rotated to get there, and because you had to go backwards, negative pi/6. Let me just say this to clarify though. When you write the pi/6 in the triangle, and again, I need a labeled triangle for your quote unquote work. I'm not asking for a whole lot there, so you need to label me a triangle. This is positive. A reference angle by definition is always positive. Your answer might have a negative because of the direction you went, but that should always be positive. All right, number 8, cosine, and it's negative. So which quadrant will that put us in? 2. Draw a triangle in quadrant 2. Now cosine is the x value. So that negative square root of 3/2 is your x value. And do you understand why that's in quadrant 2 then? Because your x value is negative, like you had to go left, right? That means this side is 1/2. And so again, what's our angle? Pi/6. Your answer is not pi/6 though. It's how far you went to get there. And just remember the denominators have to match. So what's your angle in the second quadrant with a 6 as the denominator? 5pi/6. The denominators have to match, so it has to be 6. All right, arctangent of 1. This one is a little tricky because 1 kind of makes you think of the up, down, left, right ones. If it's sine or cosine, that would be the case, but tangent, it is not. This is positive, so we're in quadrant 1. Tangent is y/x. So what do the sides have to be so that you end up getting 1? Good. They'll both be square root of 2/2 because anything over itself is 1. And so what does that mean your angle is? It's pi/4. And because you're in quadrant 1, that's your answer. When you're in quadrant 1, it's great because everything is positive and whatever you get just is your answer. So like, look at number 10. See how that's positive? That's great. Quadrant 1, and whatever we get, it'll just be our answer. So where does the square root of 3/2 go on this chart? The y value. And so what's your angle across from that? Pi/3. And so your answer is pi/3. In that case, it's not really necessary, is it? That wasn't like a part of the problem. So if you leave that off, that's fine. We didn't really need that. Because you just need to know the 2 that are across from each other. But if you want to put it there to be like really thorough, of course you can. Now, if you come across secant or cosecant, you want to reciprocate them. What is the reciprocal of secant? Which function? Cosine. So you want to rewrite this as arc cosine. And then what do you get if you flip -2? -1/2. So if you get secant or cosecant, make it sine or cosine. Those are a whole lot easier to deal with. So which quadrant is that in? It's negative, so be careful. 2, second quadrant. Where does the negative a half go? Good. Cosine is x, so negative a half goes there. That means your other side, good, square root of 3 over 2. And your angle across from square root of 3 over 2 is pi over 3. That's not your answer, though. Good, it's how far you rotated, which is 2 pi over 3. Again, the denominators have to match. Oh, this is going well. By the time we get here, I hope you could almost kind of do this one in your head. Still do the work because I'm going to give you credit for it. But can I really, do you know what the answer is going to be for this one? It'll be pi over 4. You're in the first quadrant. And it's your square root of 2 over 2 triangle. They're both sides are square root of 2 over 2. So your angle is pi over 4. And because you're in the first quadrant, that is just your answer. Still always draw me the triangle because I'm going to give you credit for that. There's only one problem on here. Well, I think there's 2 on the study guide. I think I put 1 on the test where you don't have to draw a triangle, and I'll remind you of that. All right, this one here. I'm going to go up to the top of the paper where I have some space. And when you get your test, I want you to write this next to your name. There's 2 ways this can turn out. If you have square root of 3 over 2 over a half, or a half over square root of 3 over 2. And then how they simplify down. But if this bothers you, you can always just guess you have a 50-50 shot. Put the 1/2 somewhere in the square root of 3 over 2 somewhere. But how is this one going to reduce down? Like yeah, 2's would cancel, just be square root of 3. When the 2's cancel here, you get 1 over square root of 3, be square root of 3 over 3. So which one of those did we have in the problem we're looking at? Yeah, the second one, this one right here. And first, let's figure out what quadrant we're in. Actually, it's arctangent and it's negative. So quadrant 4, draw yourself a triangle in quadrant 4. And then tangent is what over what? So watch me points to this. This is the version that we have. Tangent is y over x. So 1/2 is going to be your y value. Square root of 3 over 2 is going to be your x value. And then we'll decide what's negative. But 1/2 is y, square root of 3 over 2 is x. So that's how you can decide where they go. But it's either that or the other way around. Like it's one or the other. Which one in this case gets the negative? Which one? The 1/2. Good. And then what's your angle across from that negative 1/2? Pi over 6, but that's not your answer. It's negative pi over 6. You went backwards to get there. All right, again, if you see secant or cosecant, you're going to want to reciprocate it. So what is your reciprocal of cosecant? Which function? Sine. Okay, so it's going to be arc sine. Now, I can go through this if you want, but it's a gigantic mess, so you'd be better off just listening to me. If you flip square root of 2, you are going to get square root of 2 over 2. It's the only option that has a square root of 2 in it. Okay, like you have very, very limited choices. Thank you for heads nodding. All right. What quadrant is that in since it's positive? First quadrant. Your angle is pi over 4. And because you're in quadrant 1, it's just pi over 4. You don't have to worry about how far you rotated because it's just quadrant 1. Are we all still together? Okay. I kind of want to just get through this. Your stamina is going to have to be there. All right. Arc cotangent, and it's negative. So which quadrant is that going to be in? Since it's negative, it'll be 4. Good. And then I'm going to slide my paper down so we can go back up to the top. Do you see how it's square root of 3? I'll worry about the negative afterwards. Cotangent is what over what? X over y. All right, so look at this one. That means square root of 3 over 2 is your x. 1/2 is your y. All right, so x is square root of 3 over 2, y is a half. Then we'll decide where the negative goes. All right, so square root of 3 over 2 is here, 1/2 is here. And the 1/2 gets the negative. Again, if you feel like you can't figure it out, it's either that way or flip them around. You got a 50-50. Angle would be what? Yeah, pi over 6, but your answer is negative pi over 6. Good. Do you at this point feel like we're doing the same thing over and over again? Good, that's exactly what we're doing. Now, moving forward, these are not on the unit circle. That means everything we just did when it goes out the window. Bring back Pythagorean theorem and opposite, adjacent, and hypotenuse. Do you remember SOHCAHTOA? It's all of that, okay? So I'm going to cover up, oh, I forgot about these ones. These are the ones where you don't have to draw a triangle. Do you see how it's tangent of arctangent? They're going to cancel out. Now, you're only allowed to do that if, we talked about this last time, if the inverse is inside. If the inverse one is inside, then you can get away with just doing this. Answer is 2/3. That's the only kind that you don't have to draw me a triangle because they just cancel out. Inverse functions cancel out. Look at this one. Do you see how the inverse one is inside? Cosine and inverse cosine cancel. It'll just be negative square root of 5 over 7. So to compare and contrast, look at 18. Do you see how the inverse one is not on the inside? You're going to have to actually work out the problem. So I'm going to cover this up, and we're just going to do the part inside. This is review back from Unit 8. Do you remember the Unit 8 test where the entire back of it was just stuff like this, sine of pi or whatever and cosine of pi or whatever? All right, so what quadrant is 5/4 in? Third, good. Draw a triangle in quadrant 3. Your reference angle will be pi over 4. Again, the denominators match. And then both sides are square root of 2 over 2. And they're also both negative. Okay, so remember me saying that's like your work? It's your work. Hasn't changed. Now it says sine. Sine is the y value. Watch me point to this. It's this right here. This part I'm circling equals negative square root of 2 over 2. So I'm going to uncover this. Your next step is arc sine negative square root of 2 over 2. I think it was somebody in this class that brought this up. Hey, isn't this like that f of g of x stuff? Yeah, exactly what it is. Not like, that is what this is. You have an outside function that got hungry and ate the inside function. It's just on these ones it just canceled out. All right, so now we're doing this problem. The inverse ones are really picky. This can only be in quadrant 1 or 4. So which one is it in since it's negative? 4. So draw a triangle in quadrant 4, and it's going to be this triangle reflected over. It's the same triangle, which is kind of the point. All right, just take it and flip it over. But your answer is not pi over 4. It's negative pi over 4. Good. There's not that much more. You'll be okay. All right, let's try that again. I'm going to cover up the outside part. What you want to notice is the inverse is not on the inside. So we're going to have to actually do the problem. What quadrant is 4 pi over 3 in? Third. Okay, draw a triangle in quadrant 3. Reference angle is pi over 3. Again, the denominators just match. So what goes across from your pi over 3? Square root of 3 over 2. That means your other side is a half. And again, they're both negative. That's your work. Now it says cosine. Cosine is which part of that? X. Watch me point to this. This part I'm circling equals negative a half. So when I uncover this, we have arc cosine negative a half. And then we're going to work that one out. Again, the inverse ones are super picky. That can only be in quadrant 1 or 2. So which is it since it's negative? 2. So we're going to draw a triangle in quadrant 2. I drew a little bit too big, my negative a half. Let me erase that and make it a bit smaller. It's the exact same triangle, just reflected. So your angle is still pi over 3. It's the exact same triangle reflected up. But your answer is not pi over 3. It is 2 pi over 3. It's how far you went to get there. Good job. Four is positive. So what quadrant are we in? 1. Draw a triangle in quadrant 1. Now I would put the 4 over 1. These all need to be ratios. Cosecant is the reciprocal of which trig function? Sine. Okay, come with me on this thought journey. Sine is opposite over hypotenuse. So this is going to be hypotenuse over opposite. Coming with me there? Okay, so hypotenuse is 4, opposite is 1. Again, if you feel stuck or that was too complicated, put the 4 and the 1 somewhere and keep going. How do we get the other side? Perfect. A squared plus 1 squared equals 4 squared. So a squared plus 1 equals 16. A squared equals 15. Square root of 15. And then we're going to answer the question for outside. Again, come with me on this thought journey. Secant is the reciprocal of cosine. Perfect. Cosine is adjacent over hypotenuse. So this is going to be hypotenuse over adjacent. Good. So that would be 4 over square root of 15. Again, if that was too complicated, honestly, pick 2 of the numbers and put one of them over the other. There's only 3 sides, so you, again, don't have a whole lot of choices. You do have to rationalize that, though, so what's the final answer going to be?
4 squared
Over 15. Good. I know it looks awful, but that's the answer. You're going to do the same thing with this one. This one's negative, so quadrant 4. Cotangent is what over what? Adjacent over opposite. Or you could still think of that as x over y, I guess, if you want to. 5 is going to be the adjacent. 12 is the opposite. Which one gets the negative? The 12. Good. Now, if you remember, this is one of your locker combination ones. If you remember it, we don't have to do Pythagorean theorem. Does anyone remember it? Good. 5, 12, 13. Just saves you some work. If you don't want to remember that, just do Pythagorean theorem. It'll come out to the same answer. All right, now we're going to do cosine of that. Cosine is adjacent over hypotenuse, so 5 over 13. And there wasn't a yucky square root in it, so that was nice. These last 2 say u. We don't know what u is, so we're going to put it in quadrant 1. We're just going to assume it's positive. You have to pick a quadrant, so just pick the first one. I'm also going to put u over 1 because it has to be a ratio. And you do the problem the exact same way. There's just not a value there. Tangent is what over what? Y over x. Good. So u goes here. 1 goes here. You're going to do Pythagorean theorem. So 1 squared plus u squared equals c squared, or whatever you want to call it. Just watch me do this, because there's almost no work. What is 1 squared? 1. So I'm just going to get rid of the squared. And then to get c by itself, you would square root. And that's it. Just don't do anything to it. The only way you're going to mess it up is if you like do something. Okay. It's going to be square root of 1 plus u squared. It's going to look awful, but you just go with it. Like, just trust the process. All right. So that's your work. Now you answer the question. It says cosine. That would be adjacent over hypotenuse. So it's 1 over that awful square root. And yeah, you'd have to rationalize that. So it's going to look even worse. But again, just basically rewriting stuff. What is that going to rationalize to be? Square root of that stuff over that stuff. Good. It's the same thing you did with that 4 square root of 15 over 15. It's just a little messier. You'll be okay. Preparing you for how bad things are going to be in calculus. Go ahead.
So is there a reason you're not able to simplify that hypotenuse? Because 1 squared, 1 1.
All right, last one of these. I'm going to assume that u is positive Because I don't know what it is. You got to draw the triangle somewhere. And it says sine. So sine is what over what? Good. So 5 is the opposite. U is the hypotenuse. And then we're going to do Pythagorean theorem. So it would be a squared plus 5 squared, which would be 25, equals u squared. Then what? We're not going to square root yet. There's one more step before that. I'm sorry. You have to subtract the 25. But then, yes, square root it and then just don't do anything. Like the only way you're going to mess it up is if you do something. Just don't do anything. It's going to be square root of that stuff. Just in your brain, call it that stuff. That's, you know, when you're reading, they say that your brain really only reads the first and last letter of a word anyway. It's just like that stuff. Just think of it that way. Just those things, right? Now it says tangent. Tangent is opposite over adjacent. So it's going to be 5 over square root of that stuff. And then when you rationalize it, you're like, we hate you, Miss Cole. Numbers are fun. All right, when you rationalize it, it's going to be 5 square root of those things over that stuff. All right, these are going to be right triangles. It says a boat is being pulled in. The rope is 20 feet long. So which part of that is going to be the rope? The hypotenuse is going to be the rope. So that's the 20 feet. These are all going to ask you for the angle, which let's have this conversation right now. If you're finding the angle, what are your units? No matter what it says in the problem, degrees. So I know it seems like a tiny thing, but you have to put that little circle. That's your units. If you leave that off, I have to take off for that because it's your units. Right? It says the boat is 16 feet away from the dock. So where does the 16 go? Yeah, on the bottom. Then you're going to decide sine, cosine, or tangent. This one would be cosine. We have adjacent and hypotenuse. These are worth 3 points. It's the picture, the setup, and then the answer from typing it in the calculator. How would you type that in? And what mode do you have to be in? Degrees. So maybe just check that before you start. All right, so second cosine, 16 divided by 20. Did you get 36.869 degrees? All right. I write it this way. So that was a good question. Can you guys listen to that? I would accept it this way. Cosine x equals this. Or you can write cosine inverse of 16/20 equals x. But you can't write cosine inverse of x. If you do that, you've twisted it. Okay, so either one of these is fine. I usually do it this way. Because I worry this way is going to confuse people. All right, draw another right triangle. A man is standing 22 meters away from a building. So where does the 22 go? Bottom. He's over here. This vertical part's the building. The building is 58 meters tall. So that's the vertical part. And just put x at the bottom. You're looking for the angle. Then you're going to decide sine, cosine, or tangent. So which one is this? Tangent. So tangent of x equals 58 over 22. And then you're going to go ahead and type it in. Just I'll make sure we get the same thing. That's all that there is to that. This last one's a little silly because I made these problems. And I was trying to make one of each, cosine, tangent, so I wanted to make the last one sine. You hardly ever have the hypotenuse. It's a weird piece of information to have, is that like, so anyway, this one's a little convoluted, but just go with it. I was trying to make one of each, okay? So you've got one child up on top of a jungle gym and he's looking down at his friend. I think this one said angle of depression, but again, the sky and the ground are parallel. The angle of depression is the same as the angle of elevation. Just put x at the bottom. So one kid is up here looking down at the other kid. The jungle gym is 15 feet tall, so where does the 15 go? Yeah, the left, like the Y part, the vertical part. And then I wrote that they're 17 feet apart. So the one kid is up here and the other kid is down here. So they're 17 feet apart. I know that's so silly, but again, it's hard to get the hypotenuse into a problem sometimes. And I must have just been feeling tired and that's what I made it. So anyway, the point is, which function is it? Sine. So sine of X equals 15 over 17. Again, I was just trying, you can put that up. Oh, okay.
Sorry.
Hold on a second. All right, and so we're gonna type in second sine of 15 over 17. Oops. So X equals 61.927 degrees.